All right, so part one on our review here for inequalities. We're going to be using these with some absolute value in just a moment. So we want to refresh ourselves a little bit. And here we are. Here's some problems with inequalities, and it says solve and then graph the results. We'll treat it essentially just like an equation. The only difference is going to be that when multiplying or dividing by a negative, we'll have to reverse the symbol for the inequality, but everything else is the same. So I'm going to add 4 to both sides. And subtract x. Now we have 2x is less than 14 divided by 2. Now we're dividing by a positive, so we end up with just x is less than 7. Now, if we have a nice number line with all the tick marks on there, you can go ahead and do that, but don't take too much time if you're just hand sketching one. Just give us a little number line here with negatives on the left and positive on the right, 0 somewhere in the middle. Now we're dealing with 7, so that's gonna be on our positive side. Here's 7. It's an open circle because 7 is not one of our solutions. If we plugged in 7 right here for x, 7 isn't less than 7. It is 7. So it's an empty circle. And then plug in a test value like 0. If I plug in 0 in for x here, is 0 less than 7? Well, yeah, that's true. So we're going to shade towards 0. All right, the second one here. Multiply both sides by 7. 7 divided by 7 is 1, and that leaves us with 5 minus 2x is less than 35. Subtract 5. We have negative 2x is less than 30. Now this time when we divide, we are going to be dividing by a negative. Divide each side by negative 2, which switches our inequality around. And if you're not really sure, think to yourself, well, hey, is 1 less than 2? Yeah, that's true. Now what happens if I add, subtract, multiply, or divide by positive and negatives? Go ahead and try that out, and you can show yourself why when you're multiplying and dividing by a negative, you switch your inequality. But I'll let you work on that and figure that out on your own. For right now, again, divide each side by negative 2, so that gives us x is greater than 15. Sorry, negative 15. Sketch our number line, have 0, negative numbers, positive numbers, and that, sorry, that got kind of ugly there. That was a negative 15. That's going to be off on the left. Again, open circle. And if we plugged in a number like 0, is 0 greater than negative 15? It is, so we're going to shade towards 0. Here's 2 more quick examples. And this time we've got some fractions, but we can just get rid of our fractions. Here, if I'm looking at it, my lowest common multiple of 7 and 3 is going to be 21, so multiplying both sides by 21. 21 divided by 7, that's 3, and 3 times 2 is 6. We've got 6 times x minus 4 is less than, and over here, 21 divided by 3, or times 1/3, is going to be 7, and 7 times 2x minus 5. Go ahead and distribute out, and I think from here you guys are probably pretty solid. And go on through just like we did on that last problem. This time if you continue going, actually I'll finish it up for us. If you continue going, you've got some options here of either subtracting 14 from both sides or subtracting 6x from both sides. And either you get your x's on the right hand side or end up with a negative x. And actually we're going to subtract 6x from each side just to show us what we do if we end up with our x's on the right hand side. So we've got negative 24 is less than 8x minus 35. Add 35 to both sides, and we get, what is that going to be? 11 is less than 8x. Divide each side by 8, and we end up with 11 eighths is less than x. Now be real careful here when you're making your number line, because x is on the side we're not typically used to having it. But if we just go through that same process of reasoning through, well, is this value true or false when we substitute it in? we should end up just fine. So 11/8, that's in between 1 and 2, so kind of give yourself a little tick mark if you want. We've got 11/8 here, and once again it is an open circle. There's no or equals over here, so 11/8. And if I plugged in 0 right here, is 0 greater than 11/8? And it's not, so I'm going to shade away from 0. Last problem. I don't like the fraction, so I'm going to multiply both sides by 6. 6 divided by 2 is 3, and so I've got 3 times 3x minus 5, which is 9x minus 15. Over here, 6 divided by 3 is 2, and 2 times x minus 4 is 2x minus 8. Subtract 2x from each side, and 7x minus 15 is less than or equal to negative 8. Add our 15, and 7x is less than or equal to 7. Divide each side by 7, we get x is less than or equal to 1. And let's graph that up. Negative, positive, 0. 1 is going to be off to the right. And this time we do have that or equal, so we're going to have that circle, but we're going to color it in. It's going to be filled in because 1 is a solution this time. Now if I plugged in 0 here as my test point, is 0 less than or equal to negative 1? It is, so we're going to shade off to the left.